Here we are going to look at how to identify initial value and rate of change in a word problem and then put it into the linear equation that is in slope-intercept form. Now rate of change is just another word for slope. And what gives that away in a worded problem, it'll be something that's changing per every hour, per dollar, per kilometre, etc. An initial value simply represents the y-intercept, and it's the value that doesn't change. It's what you start with. So it's a fixed cost, a starting temperature, a starting amount. Okay, so let's have a look at the worded problems and see if we can recognise initial value and rate of change and put it into the equation. So question 1 says Sarah has a data plan that costs $12 per month plus 50 cents or half a dollar per gigabyte of downloads. Now this is slightly tricky because it has per twice. But if we have a look at how much we pay for 1 month, then how much we pay for 1 month is fixed at $12. So that has to be our initial value or our B, our y-intercept. So we have y equals something x plus 12. And then this is the one that can change in that 1 month. So our slope must be 0.5. Okay, so let's have a look at number 2. Peter has $300 in his bank account. He gets paid $11 per week to do odd chores around the home. So what does he start with? Well, he starts with $300. That's not changing. He gets paid $11 per week. So this does change because after 1 week it would be 11, 2 weeks, 22, etc. We can multiply it by the number of weeks. So this is our rate of change or our slope, and this is our y-intercept or our initial value. So if we plug them into the equation, we get y equals 11x plus 300. Now I often get asked, how do we know whether this is positive or negative? We'll just have a look at the value. Is it a negative value or is it a positive value? And then have a look at the rate of change. Is he losing $11 a week or is he gaining it? A gain is going to be a positive and a loss would be a negative. So here both values are positive. Okay, so here we have another question. A bakery starts the day with 120 loaves of bread and sells 13 loaves every hour. So what is our initial value? Which one is fixed? This is our fixed value, so that's our B, or our initial value, our y-intercept. 13 loaves is going out every hour, so that's our rate of change. So let's put that into our equation, y equals, now be careful here, we're starting with 120, so I'm actually going to write the 120 first. It doesn't matter which order you put these in, as long as your rate of change is next to your x. And I'm going to subtract 13x. Now the reason I'm subtracting 13 is because the bakery is losing those loaves every hour. It's selling them. It starts with 120. 1 hour later it has 13 less. 2 hours later another 13 less, etc. Okay, and one more. It is -5 degrees outside just before the sun rises at 6 a.m. The temperature increases by 1.5 degrees every hour until midday. So what is the change here? We've got lots and lots of numbers, so we need to figure out which ones are important. 6 a.m. and midday are not important unless we're graphing it, because that would be our domain. What we need to know is our starting point, or our initial value, and our rate of change. The 1.5 degrees is changing every hour, so that's our slope, or our rate of change. And it starts at -5 degrees. So y equals, I'm going to do in the reverse order at the top so you can see it doesn't matter. 1.5 degrees, it's increasing, so it's positive 1.5x, and it starts at -5 degrees. So that means we need to put -5, or you could have written it as starting at -5 plus 1.5 degrees every hour. Now you don't have to use y and x, and we'll get to that in another video where you define your variables. For this, for example, you could have used temperature for T and h for hour. And if you did do that, you'd have t equals 1.5h minus 5, where t is your y value equivalent and h would be your x.